Hello and welcome to this look at naming organic compounds. It's meant as an introduction really, so I'm going to stick with aliphatic alkanes and cycloalkanes in this clip. So the main thing to think about is how long is the longest chain of carbon atoms. So if we take the one at the top, obviously it reads from left to right like so, but you can also read it round the corner. So along this chain you've got 4 carbons. Along this chain you've got 5. So we go for 5 because that's the longest chain out of the 2. So that leaves us with the CH3. That will be classed as a branch or a side chain, and in this case it only has 1 carbon atom, so it will be called a methyl group. If it had 2, it would be called an ethyl group, 3 a propyl group, etc. So what we call this compound is 3-methyl pentane. If we do the same thing to the others, we can see that that will be 2-methyl hexane. Now you might be thinking, I've counted from the right, I haven't counted from the left. I'll come on to that in a second. The one at the bottom has a similar setup to the one at the top, except this time there are 6 in the longest chain, and there are 2 methyl groups. So we call this 3,4-dimethylhexane. I'll explain where the numbers come from in a sec as well. So let's clear the screen and have a look at the locant numbers. So I'm going to focus on carbon number 1 in the second one, in 2-methylhexane. Counting inwards from right to left, that keeps the locant numbers as low as possible, because the alternative we're counting from the left-hand side, and that would make the point of the branch carbon number 5. So making it carbon number 2 by counting from the right-hand side keeps the locant number as low as possible. So, looking at our 3,4-dimethylhexane, I'm going to make some more complicated examples by maybe substituting some of the hydrogens that are there for new substituents. So coming back to our locant numbers, it doesn't matter which way around you count this one, you can see quite clearly that the 2 methyl groups are situated symmetrically within the molecule, so right in the middle. So whether it's here or here, these are methyl groups here and here, it's either 3 or 4 or 3 or 4, as you can see, counting this way around or counting this way around. So let's now add a few substituents and see what happens to the naming. Now I'm going to add a substituent here because I've taken a hydrogen away. So the chlorine is now called a chloro group. Now as it stands, it would be 5-chloro-3,4-dimethylhexane. Now the issue is that locant number is quite large. But if we count from the other side, it now becomes 2-chloro-3,4-dimethylhexane. This is preferable. So let's add a fluoro group. You'll see at this point I've taken a hydrogen off here. So using the blue numbers, we've got 1-fluoro, 2-chloro, 3,4-dimethylhexane. So we've solved one problem, but we've created another. The fluoro has been placed before chloro, so they're not in alphabetical order. So we swap them round, and we bring the locant number with them. So you'll notice the locant numbers don't go numerically. We follow the alphabetical order for the first letter of the name of the substituent. So C comes before F, which in turn comes before M. So that's our correct version now. So let's have a look at cycloalkanes. So these are examples of alicyclic compounds. They have rings in them. So 2 examples are cyclopropane and cyclohexane. If you count up the molecular formulae, you get C3H6 on the left, C6H12 on the right. And they share the same general formulae as alkenes, so CnH2n. So we're going to take you through this one. So you've got 7 carbons in the main carbon ring, and you've got a methyl group here, and a methyl group here, and an ethyl group over on the right hand side here. Out of all of them, the ethyl group is the largest, so therefore that gets carbon number 1. So I'm going to count in the anti-clockwise direction, and I'm also going to count in the clockwise direction, so we can decide which way is the best way to count it. So if we take the blue numbering and the red numbering, you can see that you get 2 slightly different names. So the decision has to be made which one is correct and which one is wrong. So why is the one in blue correct? It's because the locant numbers are lower than the equivalents in the red version. So we call this compound 1-ethyl 2,5-dimethyl cycloheptane. So I'd like you to pause the clip and come back when you've thought about this one. Think about the ring first. The fact you've got 6 carbons in the ring, and then you've got an ethyl group here, a methyl here, and a methyl here. Okay, so welcome back, and let's have a look and see what you got. Hopefully you've got 1-ethyl, which is this substituent, 2,4-dimethyl, a methyl group there at carbon 2, and a methyl group there at carbon 4. Cyclo, meaning you have a ring, and hexane, 6 carbons, and it's cycloalkane. So I'm going to do the one in the top right hand corner, and then you can have a go at the one a bit further down. So first of all, why do we say 1-chloro? Obviously there's a chloro group here. Now out of the 2 substituents, the chloro group is the functional group, so that adds chemistry to this particular compound. It makes it capable of behaving as a haloalkane. The CH3 doesn't. So that means that the functional group takes precedence for position 1 over the methyl group. So that's why we're listing chloro as 1-chloro. Obviously, as we said before, we've got an alphabetical order thing going on. So C for chloro comes before M for methyl. So see if you can have a think about the one at the bottom of the screen. Pause the clip again and come back when you've finished. Okay, welcome back once more. So this one is 2,4-dibromo 1-fluoro cyclohexane. So looking at the locant numbers, I've chosen fluorine as carbon number 1 because it's more reactive than bromine. So the compound name is based on fluorocyclohexane, not bromocyclohexane. So fluorine gets position 1. 2 bromine atoms means that there's 2 bromo groups, so therefore dibromo goes into the name somewhere as well. They're at position 2 and 4, as you can see, so it must be 2,4-dibromo. We count in an anti-clockwise direction because that allows us the lowest possible locant numbers. And finally, we list the substituents in alphabetical order. Okay, so that's me done for now. Hopefully this has been a useful look at some basic naming. Until next time, thank you for listening and see you soon.